Hello, I'm Ralph Shattuck, Regional Market Manager for BG Products. I'm also a trainer for BG at BG University. So I like to go out in the field and demonstrate to people exactly what happens with our chemicals. What I'm going to do now is demonstrate the effects of BG MOA, part number 110. I'm going to demonstrate the effects of BG MOA on resistance to acid. And acids build up in your system, in your engine, at the rate of 1 to 4 pounds of sulfurous and nitrous acids every 2,000 miles of driving, approximately every 3,000 kilometers of driving. Okay? So we want to show how these harmful acids can be taken care of for a certain amount of time. The longer you extend your oil change intervals, the worse those effects become. Okay? So this is a simple way to demonstrate it. What I need for this demonstration, obviously, is a can of product. BG MOA, part number 110. I need a rag, a regular old shop rag, possibly one that's been used several times beforehand. It will be absolutely worthless after we've done this demonstration, so make sure you've got somebody's permission to steal one. Okay? Sulfuric acid, concentrated sulfuric acid, 92% pure. A pair of glasses, just in case. Okay? For me, it helps me to see anyway, but just for safety, you might need some goggles. Okay? I keep a slop bin handy and some water in case of an accident. Okay? You want to be prepared just in case. I've never really had an accident with this yet, and I've done it hundreds of times, but in case, we've got it right there. The first thing you have to do is remove any jewelry or anything like that. We don't want to run the risk of getting acid underneath those and burning yourself. So now I just have plain old hands like this. I put my glasses on and we're ready to go. Okay? First of all, to resist acid in an engine, we need what's called a total base number. A total base number shows the alkali content or resistance to acid. How long will it resist that acid before it causes a problem? The total base number of most oils to last 3,000 miles has to be a minimum of 6. For a diesel engine, it needs to be a minimum of 9 to last for 3,000 miles. That's quite impressive. 6 and 9. Diesel engine has a lot more stress added to it than a petrol engine. Higher compressions, higher tolerances, everything like that. Okay, so the only one way to demonstrate this, right here, this little can of MOA has a total base number of 33.4. That's pretty high. 33.4 compared to 6. Now it gets diluted in the oil, so it's just going to boost the total base number of that oil by about 3 points. So if it was a 6, it goes to a 9. Conversely, if it was a 3, it now goes to 6 and meets specification. And many oils do not meet the minimum specifications. Don't believe them. If you buy cheap oil, you get cheap oil. We can boost it with this. So it doesn't matter what oil we use it with, we can boost its properties. So the way to demonstrate this is, I put some MOA on my hand. Okay, simple, little puddle there like that. Now you can do this with oil and leave it in a puddle, you'll have no problem. So I rub it in like a hand cream. Okay? It has certain other properties to it as well. First of all, you'll notice that I'm giving it a nice coating absolutely everywhere, between my fingers or anything like that, so that I don't have any problems if I make a mess with the acid when I'm putting it on there. Okay? But also you'll notice that it has anti-corrosion features. So it helps protect the engine against corrosion from moisture and things like that by creating this automatic film. You'll notice that my fingernails never go rusty. Okay? That's a very important facet to it. They also say soft. Okay? But it will keep your seals in your engine nice and pliable the way they need to be in your gaskets. Okay? So all I do to demonstrate it now is I take my concentrated sulfuric acid and drip it in the palm of my hand. You know, maybe 10 drops or so. It doesn't really matter. Now we have a nice little puddle of sulfuric acid sitting right there in the palm of my hand. The reason for coating everything is if I'm talking and I tip it and it runs down between my fingers, I'm not going to burn myself. So I keep my hand flat and pour it in there. Okay? Simple? Now, what does this do with an engine? Okay, well, under normal circumstances, we build the acids inside that engine. What happens if I get a head gasket leak? A slow one or a fast one? Slowly, I'm putting ethylene glycol and water into my oil. Ethylene glycol is acidic. Water is alkali. So the two balance each other out very nicely. But the water evaporates at 100 degrees Celsius or 212 degrees Fahrenheit. That means the water goes and the acid is left behind. It etches into the metal rather rapidly if you don't have this present. Now, people don't believe that this is acid. Let me just do a quick demonstration. This is not one of the magic tricks. I'm not David Copperfield or any of these guys or Chris Angel. Okay. But we do that. I soak it up quickly and I rub it off. Okay. As you can see, the acid starts to react on the rag pretty quickly and burns a hole straight through the rag. Okay? It's nasty stuff. It's strong stuff. If I made a mistake, I would have some water there to wash off the acid because that's the only thing that really dilutes it down. So, there's our proof against acid. My hand is still okay. Okay? No problem with that. No mark on my hand. A little bit of red tinting off the rag, but that's all. Okay, which I'll wash off. But it's going to protect my hand in the same way that it protected your engine. Okay? We want maximum protection, not just friction modification, not just this. We're also going to show you how it reacts in a little while with formation of carbon inside the engine. Dramatic change to the engine, the way it reacts.